Our universe is secretly full of plot twists that break all the rules. We are about to explore 30 cosmic discoveries so baffling they challenge our fundamental understanding of physics and reality itself. By the end of this journey, you will see the cosmos in a completely new and startling way. We will encounter a mysterious force pulling thousands of galaxies toward an unseen monster and a star that dims in ways no natural phenomenon can fully explain. These are the puzzles that keep scientists awake at night. What is the one cosmic mystery you find most compelling? Our own galaxy is racing through the void at an unfathomable speed. This motion is not random, it is a desperate flight towards something we cannot see. A colossal gravitational anomaly known as the Great Attractor is pulling our entire Milky Way and thousands of neighboring galaxies toward it. We are being drawn in at a velocity exceeding 14 million miles per hour, a cosmic river flowing toward a hidden waterfall. The greatest frustration for astronomers is that this monstrous source of gravity lies directly behind the bulging center of our own galaxy, in a region we call the zone of avoidance. Here, thick clouds of interstellar gas and dust act like a cosmic curtain, blocking our view in visible light. It is like trying to identify a distant mountain peak while standing in a dense fog. How do you study a ghost, a phantom whose presence is felt only by its immense gravitational pull on everything around it? The quest to unveil this mystery required looking with new eyes. Powerful infrared and radio telescopes can peer through the obscuring dust, revealing hints of the underlying structure. Initial theories suggested the Great Attractor was a massive supercluster of galaxies, an immense gathering of matter with the gravitational muscle to command our motion. Yet, as our observations improved, we found something even more perplexing. The pull seems to originate from something far greater than a single supercluster. This has led to whispers of even more exotic possibilities. Could there be a concentration of dark matter of unimaginable scale, a gravitational anchor in the cosmos we cannot directly perceive? Or are we being pulled by something beyond the Great Attractor itself, a structure so vast it defies our current maps of the universe? This cosmic tug of war forces us to confront a humbling truth. We are not merely observers of the universe, we are participants caught in its flows, drawn toward a shadow in the sky whose true nature remains one of the deepest enigmas of our time. This invisible anchor, the Great Attractor, hints at a far more pervasive and ghostly presence woven throughout the cosmos. For every galaxy pulled by such a colossal force, another mystery holds them together from within. In the 1970s, astronomer Vera Rubin made a startling observation while studying the rotation of spiral galaxies. She found that stars at the outer edges of these galaxies were orbiting just as fast as those near the bright, dense centers. This was deeply unsettling. According to the well-established laws of gravity, these distant stars should have been moving much more slowly, like planets in our own solar system where Pluto crawls compared to Mercury. The only logical explanation was that these galaxies were surrounded by a massive, invisible halo of something that provided extra gravitational glue to keep the stars from flying off into the void. This something is what we now call dark matter. We cannot see it, touch it, or interact with it through light, yet we see its shadow everywhere. Its gravitational influence is the cosmic scaffolding that holds the universe together. When we look at massive galaxy clusters, we see a phenomenon called gravitational lensing. The immense gravity of the cluster warps the very fabric of space-time, bending the light from even more distant galaxies behind it, creating distorted arcs and mirages in the sky. The amount of bending we observe is far too great to be caused by the visible stars and gas alone. There must be 6 times more mass present, a hidden skeleton of dark matter providing the bulk of the gravitational muscle. This realization transforms our cosmic inventory. Everything you have ever seen, every star, planet, and person, constitutes less than 5% of the universe. Dark matter makes up about 27%. We know it is there by what it does, not by what it is. This has sparked a decades-long worldwide hunt to catch a ghost. Deep underground, in abandoned mines and beneath mountains, scientists have built exquisitely sensitive detectors, shielded from cosmic rays, hoping to catch the minuscule tremor of a dark matter particle bumping into an atom of normal matter. In powerful particle colliders, they try to create it. So far, the elusive substance has refused to reveal its identity. Is it a yet unknown heavy particle, a trillion of them passing through your body every second without a trace? Or does its nature require us to rewrite the laws of gravity themselves? The hunt continues, a testament to a universe that is overwhelmingly made of something we cannot see. If the gravitational pull of dark matter is the cosmic glue, then a far stranger force is actively working to tear the universe apart. This is dark energy, the dominant component of our reality, making up a staggering 68% of the cosmos. For most of the 20th century, scientists were certain of one thing about the universe's expansion. The mutual gravity of all matter, both seen and unseen, was acting like a cosmic brake, gradually slowing the rate at which galaxies were flying away from one another. The only question was how long it would take for this expansion to grind to a halt. Then, in 1998, two independent teams of astronomers made a discovery so shocking it overturned a fundamental pillar of cosmology and won them the Nobel Prize. They were observing a specific type of exploding star, a supernova, that acts as a standard candle, allowing for precise distance measurements across vast cosmic stretches. By studying these supernovae in incredibly distant galaxies, they were effectively looking billions of years into the past. They expected to see the expansion slowing down in the early universe. Instead, they found the opposite. The expansion of the universe is not slowing down at all. It is accelerating. Galaxies are flying apart from each other faster and faster with every passing moment. It was as if you threw a ball into the air, and instead of falling back down, it shot away from you at an ever-increasing speed. Some mysterious repulsive force, a kind of anti-gravity, is pushing the very fabric of space itself outward. This is the essence of dark energy. The implications for the ultimate fate of everything are profound. The leading theory points toward a big freeze, an eternal, cold, and lonely end. As space expands at an ever-accelerating rate, distant galaxies will be pushed beyond our cosmic horizon, their light forever too faint to ever reach us again. The universe will become a vast, dark, and empty void, with isolated islands of stars growing ever more distant. But there is an even more dramatic and terrifying possibility known as the Big Rip. If the strength of dark energy increases over time, it might not just push galaxies apart. Billions of years from now, it could overcome the gravitational forces holding individual galaxies together, tearing stars from their orbits. Later, it could rip planets from their stars. In the final moments, it would overcome the forces holding atoms together, shredding every molecule, every particle of matter in existence into a mist of disconnected fragments. The central puzzle is as deep as it gets. What is the nature of this repulsive energy that makes up the bulk of reality? Is it a property of empty space itself, a constant energy density woven into the vacuum, as Einstein once briefly suggested with his cosmological constant? Or does it stem from a new dynamic energy field that permeates the cosmos, one we have yet to understand? We are left with a universe whose dominant force is a complete mystery, an emptiness that pushes, dictating a future that seems increasingly alien and inevitable. While dark energy dictates the future of the cosmos, a single, fleeting event from our own backyard suggests we may not be alone in it. On a quiet Ohio night in August 1977, the Big Ear radio telescope was engaged in its routine sweep of the sky, listening for whispers from the cosmos. Volunteer astronomer Jerry Amon was reviewing the computer printout, a long scroll of paper filled with rows of numbers and letters representing the faint radio noise the telescope had collected. His eyes scanned a sequence that was utterly ordinary until they landed on a string of characters so extraordinary he circled it in red pen and wrote one word beside it. Wow! For 72 seconds, the telescope had recorded a signal that was not just strong, but perfectly crafted. It blasted onto the frequency of the hydrogen line, a universal channel that scientists had long speculated would be the logical choice for an interstellar broadcast. The signal rose to a stunning peak in intensity and then faded away exactly as expected, matching the precise window of time a stationary signal would be in the telescope's fixed field of view. It was a perfect bullseye, a burst of radio energy that looked exactly like a deliberate beacon. The search for a repeat began immediately. Astronomers pointed every available instrument back toward that same patch of sky in the constellation Sagittarius, listening for another call. They listened for months, then years, and then decades. The silence was absolute. The wow signal never returned. So what was it? The signal's artificial seeming characteristics point toward an intelligent origin, a one-time transmission from a civilization far away. Yet its singular nature is also its greatest puzzle. A genuine interstellar beacon would likely be repetitive, designed to be noticed. This was a cosmic flash in the pan. Skeptics have proposed natural explanations, from a comet that was not in the area at the time to a signal reflected off a piece of space debris. But none have fully matched the unique and powerful profile of that 72-second event. It remains astronomy's most famous ghost, a tantalizing possibility that for one brief moment we were listening and someone or something seemed to be calling. While we scan the heavens for signals, a star 1,500 light-years away is performing a light show so bizarre it defies every conventional explanation. This is Tabby's star, officially known as KIC 8462852, and its strange behavior was first spotted not by a professional astronomer, but by a group of dedicated citizen scientists. They were sifting through the immense trove of data from the Kepler Space Telescope, which meticulously measured the brightness of stars to find the telltale dips caused by orbiting planets. Most stars showed predictable, gentle dimming. Tabby's star was different. It displayed sudden, catastrophic drops in brightness. Not the tiny 1% dip a Jupiter-sized planet would cause, but plunges of up to 22%, as if something enormous and utterly opaque were drifting in front of it. The strangeness did not end there. These dramatic dimming events were completely irregular. They did not follow a predictable schedule. Sometimes the star would dim sharply for days, then return to normal. Other times it would flicker erratically. This ruled out the simple, elegant clockwork of a planetary orbit. It was the celestial equivalent of someone randomly turning a dimmer switch up and down with no discernible pattern. The scientific community was captivated and confounded. What could possibly block a star's light in such a violent and chaotic way? The hunt for a plausible explanation began, leading to theories that range from the natural to the nearly unimaginable. One early idea proposed a colossal swarm of comets, thousands of them, surrounded by vast clouds of dust and debris passing in front of the star. While this could explain the irregularity, the sheer scale required is staggering, a number of comets far beyond anything we see in our own solar system. Then came the more speculative and far more thrilling hypothesis. Could we be witnessing the construction of an alien megastructure? The concept, first proposed by physicist Freeman Dyson, imagines a vast shell or swarm of solar collectors built by an advanced civilization to harness the entire energy output of its star. Such a structure, incomplete and uneven, could perfectly account for the strange, aperiodic dimming patterns. The idea sent a jolt of excitement through the world of astronomy, a legitimate scientific possibility, however remote, that we were seeing the fingerprints of intelligence on a cosmic scale. Subsequent observations have cast doubt on the alien megastructure theory, finding that the dimming affects some wavelengths of light more than others, which suggests the material blocking the light is likely fine dust, not solid panels. Yet the mystery has only deepened. This dust itself is a puzzle. Where did it come from, and what process is creating it in such vast and irregular quantities? The star remains under intense scrutiny, a celestial oddball that refuses to give up its secrets, reminding us that sometimes the most profound discoveries are not answers, but questions that force us to reconsider what is possible. Our own galaxy alone contains billions of planets that could be cradle for life, a staggering number of potential neighbors. This abundance leads directly to a haunting question first posed by physicist Enrico Fermi. If the universe is so vast and so old, with so many chances for intelligence to arise, then where is everybody? The silence is deafening. This is the Fermi paradox, the profound contradiction between our high expectations for a crowded cosmos and the complete absence of any proof. We scan the skies for signals and see only static. We search for engineering on a cosmic scale and find none. The universe appears to be a ghost town, beautiful but empty. Scientists have proposed many chilling solutions to explain this great silence. One possibility is that space is not a welcoming place for long-term survival. The dark forest hypothesis suggests the cosmos is like a dark woodland where every civilization is a hidden hunter. To broadcast your location is to invite destruction from a potentially predatory neighbor, so every advanced society chooses to remain utterly silent, leading to a universe frozen in mutual suspicion. Another, even more sobering idea is the concept of a great filter. This theory proposes that there exists some kind of barrier, an evolutionary or technological challenge so difficult that nearly every civilization fails to overcome it. This filter could lie in our past, a step so improbable that we are a cosmic miracle, one of the very few to have made it this far. Perhaps the development of complex life itself is the astronomical fluke. Or, and this is the more frightening prospect, the great filter lies in our future. It could be that almost all technological civilizations inevitably destroy themselves upon discovering a certain technology, perhaps nuclear weapons, engineered pathogens, or a runaway artificial intelligence. Our continued existence would then not be a miracle but a warning. We may simply be ahead of schedule, living on borrowed time before we inevitably confront the same wall that has silenced every other voice in the cosmos. The eerie quiet of the universe may be telling us something crucial about our own destiny. This profound cosmic silence makes the sudden, violent screams we do occasionally hear from the dark all the more startling. From the depths of intergalactic space come bursts of raw power so immense they defy belief, vanishing almost before they are registered. These are fast radio bursts. In a single millisecond, less time than it takes to blink, one of these events can release as much energy as our sun puts out over 80 years. Imagine compressing the entire lifetime output of a star into a fleeting cosmic snap of the fingers. The first of these bursts was discovered in 2007, hidden in archived data from a radio telescope in Australia. It was so brief and brilliant that for years astronomers debated whether it was a glitch, an instrument error. But then more were found. These flashes are not local. They travel for billions of years from distant galaxies before a few of them are caught by our most sensitive dishes. The initial mystery was their source. What kind of cosmic catastrophe could be so powerful, so instantaneous, and so devastating? The logical assumption was a one-time, self-destructing event, the final death cry of a star being shredded by a black hole or the collision of two incredibly dense objects. But then came an even bigger surprise. In 2016, astronomers found a source that repeated. It was not a single cataclysm. This same object in a galaxy far away was firing off multiple bursts, sometimes in a frantic, erratic pattern. This single discovery shattered the model of a one-time explosive event. Whatever is creating these bursts is capable of surviving them, a cosmic engine that can fire again and again. So what cosmic engine could possibly power such a phenomenon? The prime suspect is a type of neutron star called a magnetar. These are the universe's ultimate magnets, stellar corpses with magnetic fields so intense they could erase a credit card from halfway to the moon. A starquake on the surface of a magnetar, a sudden cracking of its rigid crust, could theoretically unleash a titanic shockwave, rippling out into space as a blistering flash of radio waves. Another possibility is the violent interaction between a magnetar and the disk of material surrounding a black hole, a chaotic environment ripe for immense energy releases. While these natural explanations are compelling, the sheer, focused power of these bursts has inevitably led to more speculative ideas. Could we be witnessing the byproduct of unimaginably advanced technology? Some scientists have cautiously proposed that such a focused, high-energy signal could be evidence of interstellar light sails, powered by gigantic radio transmitters to push spacecraft to near light speeds. A single burst could represent the launch of a vessel across the galactic void. It is a fringe hypothesis, but it highlights just how extraordinary these events truly are. They are brief, brilliant, and deeply enigmatic messages from the far reaches of the universe, written in a language of pure energy we are only just beginning to decode. Sometimes the greatest mysteries are not announced with a flash but with a whisper. Far beyond the orbits of the planets, two human-made explorers, Pioneer 10 and Pioneer 11, were continuing their silent journeys into the void. Back on Earth, scientists meticulously tracked their trajectories, expecting their speeds to be governed by the predictable pull of the Sun's gravity. Yet a tiny, persistent anomaly emerged. Both spacecraft were slowing down just a little bit more than they should have been. It was an almost imperceptible deceleration, a constant, gentle tug back toward the Sun equivalent to a 10 billionth of the gravity we feel on Earth's surface. For over a decade, this pioneer anomaly was a thorn in the side of physics. Such a consistent, unexplained effect pointed toward something profound. Could it be evidence of a subtle error in Einstein's theory of general relativity? Was there some unseen, diffuse cloud of dark matter in our solar system exerting an extra drag? Or were we seeing the first hints of entirely new laws of physics, a force that only became noticeable in the deep, cold quiet of interplanetary space? The implications were staggering, suggesting our most fundamental understanding of gravity might be incomplete. The solution, when it finally came, was not found in the grand equations of cosmology, but in the mundane reality of engineering. The culprit was heat, specifically the faint but constant thermal radiation emitted by the spacecraft's own radioactive power generators and electrical systems. As this heat radiated away from the spacecraft, it carried with it a tiny amount of momentum. It was a phenomenon known as thermal recoil. Picture a simple example, a child's balloon. If you inflate it and let it go, it flies wildly around the room as the air rushes out. The Pioneer spacecraft were doing the same thing, but in an incredibly subtle way. The heat escaping preferentially from the side of the craft facing the Sun was acting like a tiny, continuous thruster, providing just enough push to create the observed deceleration. Once scientists built a highly detailed model of the spacecraft, accounting for every watt of power and how it was radiated as heat, the anomalous drift vanished. The mystery was solved, yet the Pioneer anomaly remains a powerful cautionary tale. It reminds us that in the extreme precision of deep space navigation, there is no such thing as an insignificant detail. The faint glow of a warm spacecraft can mimic the signature of new physics. It teaches a humbling lesson about the universe and our place in it. Before we invoke dark matter or rewrite the laws of gravity, we must first be certain we are not simply measuring our own reflection. In 2017, our solar system received its first confirmed visitor from another star. Racing through the space between worlds, This object was spotted by the Pan-STARRS telescope in Hawaii and named Oumuamua, a Hawaiian word for scout from the distant past. Its trajectory was the first clue to its alien origin, a hyperbolic path proving it was not bound to our sun, but its physical characteristics were what truly baffled astronomers. Unlike any asteroid or comet we had ever seen, Oumuamua appeared to be highly elongated, shaped like a cosmic cigar or a pancake tumbling through the void. Its length was estimated to be up to 10 times greater than its width, a form factor never before observed in a natural celestial body. Even more puzzling was the way it moved. As it sped away from the sun, it exhibited a slight but definite non-gravitational acceleration. It was picking up speed in a way that could not be explained by the gravity of the sun or planets alone. A comet would do this through outgassing as the sun's heat vaporizes ice, creating a jet of gas that acts like a natural rocket engine. Yet when astronomers pointed their most powerful telescopes at Oumuamua, they saw no visible coma, no tail of gas and dust streaming behind it. It was dark, reddish, and seemingly barren, a silent, inert rock. This contradiction sparked an intense scientific debate that continues to this day. How could something accelerate without the telltale signs of outgassing? One compelling natural explanation suggests Oumuamua was a new type of object, an interstellar hydrogen iceberg. In the cold depths of interstellar space, molecular hydrogen could freeze solid. As this iceberg neared our sun, the theory goes, the warming caused the solid hydrogen to turn directly into a gas, jetting away invisibly and providing the push that altered its course. This would explain the acceleration without a visible coma. However, the object's strange shape and the precise nature of its push led others, most notably Harvard astronomer Avi Loeb, to propose a far more radical idea. He suggested we could not rule out an artificial origin. What if Oumuamua was a piece of advanced technology, a discarded light sail from an extraterrestrial civilization drifting among the stars? A thin, wide light sail pushed by the radiation pressure from starlight could account for both the unusual shape and the non-gravitational acceleration. This hypothesis, while controversial, forced a crucial conversation about the limits of our scientific imagination. Are we too quick to dismiss possibilities that seem like science fiction, or is it our responsibility to consider all explanations, no matter how extraordinary, when faced with a genuine anomaly? Oumuamua is now long gone, vanishing into the dark, leaving behind only a trail of data and a profound question. Was it a strange, natural rock, a testament to the diversity of objects sailing between stars, or was it our first brush with a relic from another world, a silent, passing ship from a civilization we may never know? Even the echo of creation itself holds a flaw that should not exist. As we map the faint afterglow of the Big Bang, the cosmic microwave background, we find the universe is remarkably uniform, a nearly perfect tapestry of minute temperature variations. But one patch of this sky is profoundly different. Known as the cold spot, it is an immense region of space over 1 billion light-years across that is significantly colder than its surroundings. It is a cosmic anomaly of staggering proportions, a ghostly bruise on the fabric of reality. At first, astronomers thought they had a simple explanation. This must be a supervoid, an enormous and mostly empty region of space. As light travels through such a void, it loses energy climbing out of its gravitational well, a process known as the integrated Sachs-Wolf effect, which should cause a slight cooling in the background radiation we observe. But there is a devastating problem. The scale of the cold spot is simply too vast. The void required to create such a pronounced cold area would need to be of a size and emptiness that standard cosmology deems nearly impossible to form in the lifetime of our universe. The observed supervoids we have found in that general direction are not nearly large or empty enough to account for the profound chill. The effect is far stronger than the cause. This leaves us with a gaping hole in our understanding. If it is not a void, then what carved this frigid scar into the infant universe? One of the most mind-bending proposals is that we are seeing evidence of a cosmic collision. The theory of the multiverse suggests our universe is just one bubble in a vast, frothing cosmic foam of other universes. If another bubble universe brushed against our own in the first moments of inflation, the energy of that collision could have left a permanent imprint, a cold spot where the fabric of our reality was subtly disturbed by the touch of another. This is not just a mathematical curiosity. It is a potential glimpse beyond the confines of our own cosmos, a suggestion that the ultimate structure of reality is far grander and more strange than we ever conceived. The cold spot remains a profound puzzle, a cosmic wound that either reveals the limitations of our current models or opens a window to an infinite sea of other worlds. The faint afterglow of the Big Bang holds another, even more unsettling secret. As scientists meticulously mapped the subtle temperature variations in the cosmic microwave background, they expected to find a random, chaotic distribution, a fingerprint of the universe's violent birth with no discernible pattern or preferred direction. This expectation is rooted in the cosmological principle, a cornerstone of modern physics which states that the universe on a large scale is homogeneous and isotropic. It should look the same in every direction with no special place and no central axis. Yet, the data revealed something that sent a chill down the spines of cosmologists. The fluctuations in this primordial light appear to be aligned. They are not completely random. Astonishingly, this apparent preferred direction in the cosmos seems to correlate with the plane of our own solar system and the direction we are moving through space. Scientists have given this eerie correlation a dramatic name, the axis of evil. The name is not an exaggeration. If this alignment is real and not some grand statistical fluke, it strikes at the very heart of our cosmic assumptions. It suggests that either we occupy a uniquely central and special place in the universe, a concept science discarded centuries ago, or there is a fundamental flaw in our understanding of the universe's infancy. How could the oldest light in creation possibly know or care about the insignificant orientation of our tiny solar system billions of years later? One possibility is that this is a colossal coincidence, a trick of the data. Perhaps when we look at the entire sky from our single vantage point, the way we process the information introduces subtle biases that create the illusion of an alignment. It is like looking at a vast, random splatter of paint, and from one specific angle, imagining you see a face. Researchers have tirelessly worked to rule out such local effects, from the influence of our galaxy's dust to errors in the instruments themselves, yet the peculiar signal has proven stubbornly persistent. If it is not an illusion, the implications are profound. It could mean that the universe is not isotropic after all. It might have a large-scale structure, a grain or a flow that we are only just beginning to perceive. Some theories even suggest this axis could be a relic of the pre-Big Bang universe, a scar from the mysterious process of inflation that set everything in motion. The axis of evil is a quiet, statistical mystery, but it carries a deafening question. Are we, against all odds, at the center of a cosmic pattern, or is the universe far stranger and more structured than our most cherished principles allow? If the axis of evil suggests a hidden structure in the cosmos, then the Boötes void is a monument to cosmic absence. Picture a spherical region of space so vast it could contain thousands of galaxies like our own, yet it holds almost none. This is the Great Nothing, a void spanning over 300 million light-years where the normal rules of the universe seem to have been suspended. Its emptiness is so profound that if our Milky Way were at its center, we would not have known other galaxies existed until the 1960s. How does a chunk of the universe on a scale almost impossible to comprehend end up so barren? The standard model of cosmology paints a picture of a cosmic web, an intricate structure where galaxies form along dense filaments of dark matter separated by great empty bubbles. The Boötes void is one of these bubbles, but it is an extreme outlier, a cavern of such staggering size that it defies our expectations. Matter should be distributed more evenly. The void we observe is far emptier than our simulations of the cosmos predict. It is not a perfect vacuum, of course. A handful of lonely galaxies have been found drifting in this immense darkness, like isolated ships on an endless black ocean. Their very presence deepens the mystery. Why did so few galaxies form here when the surrounding universe is teeming with them? What prevented the normal processes of gravitational collapse and star formation from taking hold across this enormous volume? One theory suggests this great emptiness is not a single void, but the result of several smaller voids merging together over billions of years, their emptiness combining to create a single colossal pocket of nothing. Another, more exotic idea proposes that some unknown property of this region, perhaps a peculiar distribution of dark matter or a remnant feature from the Big Bang itself, actively suppressed the birth of galaxies. The Boötes void stands as a silent challenge to our maps of the cosmos, a stark reminder that the universe may reserve its most profound mysteries not in the brilliant clusters of matter, but in the vast, echoing spaces between them. Deep within the heart of a black hole lies a paradox that threatens to unravel our understanding of reality itself. This is the black hole information paradox, a battle between two of our most successful physical theories, general relativity and quantum mechanics, and it all hinges on a simple but profound question. What happens to the information about an object that falls in? According to Einstein's theory, the gravitational pull is so intense that anything crossing the event horizon is lost forever, crushed into the singularity. All the intricate details that made up a star, a planet, or a book, its atomic structure, its spin, its composition, are seemingly erased from the universe. This presents no problem for relativity, but it is a catastrophic violation of a sacred rule in quantum mechanics. Quantum physics insists that information can never be truly destroyed. It can be scrambled, hidden, or transformed, but it must, in principle, be recoverable. For decades, physicists assumed the problem would resolve itself, that some future theory of quantum gravity would explain how the information was preserved inside the black hole. Then Stephen Hawking stepped in and turned the problem into a full-blown crisis. He realized that black holes are not completely black. Due to weird quantum effects occurring right at the event horizon, they slowly leak radiation. This Hawking radiation is incredibly faint, but over astronomical timescales, it causes the black hole to lose mass and eventually evaporate completely, vanishing in a final puff of energy. And here is the crushing blow. Hawking calculated that this radiation is purely thermal. It is random noise, like the heat coming from a stove. It contains no information whatsoever about what fell into the black hole. So when the black hole evaporates, the information it once contained is gone forever, erased from existence. The universe would have a fundamental case of amnesia. This conclusion was so unsettling that most physicists, including Hawking himself, believed there had to be a mistake. The search for a solution has led to some of the most mind-bending ideas in modern physics. One leading proposal is the holographic principle. It suggests that all the information about everything within a black hole's three-dimensional volume is not stored inside at all. Instead, it is encoded on a two-dimensional surface, the event horizon, like a cosmic fingerprint. The three-dimensional world we experience could be a projection from this encoded data, much like a hologram emerges from a flat sheet. When the black hole evaporates, this information is slowly and chaotically released back into the universe through the Hawking radiation, scrambled beyond easy recognition but not destroyed. Another, more violent solution is the firewall hypothesis. It proposes that the event horizon is not the smooth gateway described by Einstein. Instead, it is a searing wall of unimaginable energy, a literal firewall that would instantly incinerate anything falling in. This firewall would prevent information from ever actually entering the black hole, resolving the paradox by saying the information is burned up at the door. But this creates its own problems, violating the principle of equivalence, which states that an astronaut falling through the event horizon should feel nothing special, at least not until the tidal forces later rip them apart. So we are left with a choice between seemingly impossible answers. Is our universe a holographic projection? Do black holes have deadly firewalls at their boundaries? Or is there a solution even more bizarre waiting to be discovered? The fate of information, and with it the logical consistency of our physical laws, depends on the answer. Even the recipe for the universe itself seems to have a crucial ingredient missing. When we look back to the first few minutes after the Big Bang, we can calculate with stunning precision how much of the lightest element should have been forged. The predictions for hydrogen and helium match the ancient cosmos perfectly, a triumphant confirmation of our origin story. But for the third element, lithium, the math falls disastrously short. The oldest stars in our galaxy, which act as cosmic time capsules preserving the pristine chemistry of the early universe, contain only about 1/3 of the lithium-7 that our models insist should be there. This is not a small rounding error. It is a fundamental discrepancy, a gap in our understanding of creation's first moments. How could the universe get the first two ingredients so perfectly right and botch the third so completely? This lithium problem is a quiet but persistent crack in the foundation of the Big Bang theory. One line of inquiry suggests the solution lies in the realm of exotic particle physics. Could unknown particles, such as a type of dark matter, have been present in the early universe, altering the nuclear reactions that built lithium? These phantom particles might have changed the rate at which atomic nuclei collided and fused, effectively destroying some of the lithium as it was being born. Other scientists look toward the stars themselves for an answer. Perhaps these ancient stellar furnaces are not the pristine relics we assume them to be. Internal processes like turbulent churning that drags material deep into a star's core could have slowly burned away the original lithium over billions of years, erasing the primordial signature. Yet, finding a stellar model that destroys exactly the right amount of lithium without affecting other elements has proven incredibly difficult. The lithium problem endures because every proposed solution seems to create new puzzles of its own. It is a ghost in the cosmic machine, a reminder that our most successful story of how everything began may still be missing a vital page. While black holes threaten to erase information, a world closer to home presents a mystery of breathtaking geometry. At Saturn's North Pole, a storm rages on a scale that dwarfs our entire planet. This is no ordinary hurricane. It is a perfect, persistent hexagon, a six-sided jet stream etched into the atmosphere like a colossal cosmic snowflake. For decades, this stunning formation has defied the fundamental laws of fluid dynamics, which dictate that turbulent, spinning systems in nature should form ovals or simple circles. Think of the Great Red Spot on Jupiter, a massive but fundamentally oval storm. The appearance of such a sharp, geometric shape in a gaseous environment is as unexpected as finding a perfect cube carved by a river. The hexagon is a fixed feature, a rotating weather pattern with sides each longer than the diameter of Earth, and it has remained stable across multiple Saturnian seasons, outlasting every human civilization. How can a fluid, chaotic atmosphere lock itself into such a rigid, mathematical form? Scientists have turned to laboratories to find an answer. By spinning a cylinder of fluid, they can simulate the conditions of a planetary pole. When the inner cylinder rotates faster than the outer one, something remarkable happens. Under the right conditions, stable, polygonal shapes emerge within the swirling liquid. The hexagon appears when the difference between these rotation speeds hits a specific threshold. This suggests that Saturn's hexagon is a standing wave pattern, a stable oscillation trapped in the planet's churning atmosphere, much like a specific note can make a guitar string vibrate in a precise shape. Yet the laboratory models only deepen the awe. They can create the shape, but they cannot fully replicate the staggering scale and unbelievable endurance of the phenomenon on Saturn. What precise combination of wind speeds, atmospheric density, and planetary rotation maintains this perfect symmetry across an area of billions of square miles for decades on end? The Saturn hexagon is more than a beautiful curiosity. It is a natural laboratory testing the limits of our understanding, a reminder that even the laws of physics can paint with a surprisingly geometric brush when we are not looking. From the geometric perfection of Saturn's pole, we shift to the invisible bullets constantly raining down on our planet. These are cosmic rays, subatomic particles flung across the universe at nearly the speed of light. Most are protons or atomic nuclei, and while they are common, a rare few carry an energy so monstrous it defies belief. We call these ultra-high-energy cosmic rays, and they hit our atmosphere with the force of a professionally thrown baseball, all compressed into a single, minuscule particle. This is an energy level millions of times greater than what we can achieve in our most powerful particle colliders, like the Large Hadron Collider. These particles are nature's own ultimate accelerators, and their existence presents a profound puzzle. There is a fundamental speed limit for such particles traveling across the universe, a theoretical boundary known as the Greisen-Zatsepin-Kuzmin cutoff, or simply the GZK cutoff. The space between galaxies is not completely empty. It is filled with the faint, cold glow of the cosmic microwave background, the leftover heat from the Big Bang. For a proton traveling at such an insane energy, this background radiation is no longer a gentle whisper. It appears as a dense wall of high-energy gamma rays. Every collision between this ultra-fast proton and a background photon is like a car crashing into a brick wall at relativistic speeds. The proton should be rapidly slowed down, losing its immense energy over a relatively short cosmic distance. According to this limit, no particle with energy beyond this cutoff should be able to reach us from further than about 150 million light-years away. The universe, it seems, should have a built-in speed bump for these cosmic bullets, yet we detect them. Our observatories, like the sprawling Pierre Auger Observatory in Argentina, have recorded these events. This means these particles are not coming from the distant, ancient universe. Their source must be within our local cosmic neighborhood, a sphere of galaxies relatively close to our own. And whatever is creating them must be an engine of almost unimaginable violence, capable of accelerating a single particle to energies we can barely comprehend. So what cosmic catastrophe is powerful enough to serve as this particle cannon? The suspects are as dramatic as the crime itself. One candidate is an active galactic nucleus, where a supermassive black hole at the center of a galaxy is devouring matter and spewing out colossal jets of energy. Another is a gamma-ray burst, the most energetic explosion since the Big Bang, triggered by the collapse of a massive star or the merger of two neutron stars. Shockwaves from colliding galaxies could also, in theory, provide the necessary boost. The great frustration is that when we trace the arrival direction of these ultra-high-energy rays back into the sky, we find no obvious smoking gun. The particles are charged, so their paths are bent and scrambled by the magnetic fields that weave through interstellar space, blurring their point of origin. We are left with a map that points to vast, empty regions of sky, with no brilliant cataclysm or monstrous black hole to blame. It is as if we are being sniped by a ghost, a hidden cosmic accelerator operating in plain sight, yet remaining utterly invisible to our searchers. The universe is firing its most energetic particles at us, and we still have no idea who is pulling the trigger. The cosmos can paint with a ruler as well as a chaotic brush. Far from the violent storms of Saturn lies another geometric wonder, a celestial structure so precise it seems to defy the very nature of stellar death. Known as the Red Rectangle Nebula, it is the spectacular final act of a dying star system, located about 2,300 light-years away in the constellation Monoceros. Through our most powerful telescopes, it does not appear as a wispy, round cloud, but as a series of stark, nested rectangles, a cosmic honeycomb glowing with a deep crimson light. At its very heart, a strange ladder-like structure of rungs stretches between the corners, completing a picture that looks less like an astronomical object and more like a piece of alien architecture. This is not what we expect from the explosive, messy demise of a star. When sun-like stars reach the end of their lives, they typically puff off their outer layers in a series of uneven, sputtering bursts, creating the beautiful but amorphous shapes of planetary nebulae. The red rectangle is something else entirely. Its sharp, symmetrical form suggests a process of incredible control and precision. The secret to this geometry lies in the heart of the system, a pair of stars locked in a tight gravitational dance. The leading theory suggests that as the primary star began its death throes, it ejected vast quantities of gas and dust. But instead of expanding outward in a sphere, this material was funneled into two dense, opposing cones by the powerful gravitational influence and a thick disk of dust surrounding the second star. From our vantage point on Earth, we are looking directly down the barrel of these twin cones. The edges of the cones, where the densest gas and dust are concentrated, create the illusion of the nested rectangles, while the strange rungs across the center may be caused by sudden, periodic bursts of material ejected from the binary system. It is like watching two immense cosmic hourglasses placed back to back, with sand steadily streaming out to form a perfectly defined shape. Yet, even this elegant model cannot fully explain the breathtaking perfection of the X shape. The mechanism that sculpts the gas and dust with such mathematical clarity, creating a structure that has remained stable for centuries, remains one of astrophysics' most beautiful puzzles. The Red Rectangle Nebula stands as a stunning reminder that the universe has a hidden sense of order, a capacity for geometry that emerges from chaos, leaving behind a work of art etched across the night sky. The strangeness of Tabby's star runs far deeper than its sudden, erratic dips. Astronomers digging into century-old photographic plates uncovered a chilling long-term trend. This star has been steadily, inexorably dimming for over 100 years. While the star flickers dramatically from month to month, the overall baseline of its light has been fading, as if a colossal shadow is slowly creeping across its face. This is not the signature of a simple swarm of comets, which would cause short-term dips but not a persistent, century-long decline. It points to a process unfolding on an epic scale, something vast and systematic gradually blocking the star's light. More recent observations have added a crucial piece to the puzzle, narrowing the field of suspects. Detailed analysis of the dimming revealed a key clue. The star dims more in some wavelengths of light, specifically ultraviolet and blue light, than it does in infrared. This is the fingerprint of dust. Tiny particles of dust, smaller than a grain of smoke, scatter and block shorter wavelengths more effectively, letting the longer, redder wavelengths pass through. This evidence strongly points away from solid, opaque structures and toward an immense, uneven cloud of fine dust orbiting the star. But solving one mystery has only birthed another, perhaps even more perplexing. Where is this enormous amount of dust coming from, and what is creating its bizarre, asymmetric distribution? One compelling theory suggests a cataclysmic event in the star's recent past. A moon or a planet may have been gravitationally torn apart, its body shattered into a colossal ring of debris that now circles the star in a lopsided, clumpy swarm. This would explain the irregular dimming and the presence of dust. Yet, the mechanics of such a disruption are fiendishly complex. What kind of event could cause this? A violent collision between two worlds, a close gravitational encounter with a passing star that stirred up the system. The dust itself is another enigma. Ordinary dust, constantly bombarded by the star's intense light, should either be blown away by radiation pressure or slowly spiral inward over time. The fact that so much dust remains, causing a century of dimming, means it must be continuously replenished by some ongoing process. A grinding cascade of collisions within a vast asteroid belt could do it, but the scale required is once again staggering. So we are left with a celestial detective story where the prime suspect has been identified, but the motive and the murder weapon remain elusive. We know dust is the culprit, but its origin is a cosmic crime scene we are still struggling to interpret, a ghostly shroud that keeps the star's deepest secret hidden. Solving the riddle of the cold spot means confronting two wildly different possibilities, one rooted in the emptiness of space and the other in the shattering of reality itself. The most straightforward explanation is the supervoid theory. The integrated Sachs-Wolfe effect describes how light loses energy as it travels through an expanding region of cosmic emptiness. Climbing out of a vast gravitational well requires work, and that work saps the light's energy, making it appear colder in the cosmic microwave background. It is a well-understood process, a predictable outcome of an emptier-than-average patch of the universe. The problem is one of scale. While astronomers have indeed found a large supervoid in the general direction of the cold spot, it is a puddle trying to explain an ocean. This void is simply not vast enough or empty enough to account for the profound and immense chill we observe. The effect is far too strong for the proposed cause, leaving a gaping deficit in our understanding. This failure of the simple explanation forces us to consider something far more exotic, like a flaw in the very fabric of space-time known as cosmic texture. This theory suggests that as the infant universe underwent a phase transition, cooling and expanding, it may not have done so perfectly smoothly. A cosmic knot, a defect in the structure of reality itself, could have formed. If such a knot were to unravel, it would release a tremendous burst of energy, creating a gravitational well that would subsequently repel matter. Light passing through this repulsive region would not lose energy but gain it, making it appear hotter. However, the light traveling through the surrounding, now matter-depleted region would experience the opposite, losing energy and creating the colossal cold spot we see today. It is a cosmic bruise left by a singularity in the vacuum of space. An even more radical proposal involves the multiverse. If our universe is just one bubble in an infinite cosmic foam, then the cold spot could be the scar from a collision with another bubble universe in the first fleeting moments of inflation. The energy of that impact would have left a permanent, localized imprint on our cosmos, a cold blemish where the fundamental fields of our reality were disturbed by the touch of another. While these ideas sound like science fiction, they are serious, mathematically grounded attempts to explain an observation that our standard model cannot. The cold spot, therefore, is more than just a cold patch on a map. It is a direct challenge. It is either a sign that we profoundly misunderstand the distribution of matter in the universe, or it is our first potential glimpse of physics operating on a scale beyond our own cosmos. For now, it remains one of the most significant and unexplained anomalies in our entire map of creation. Lurking in the heart of a distant galaxy cluster is a cosmic fossil, a living relic from the dawn of time. This is NGC 1277, a galaxy that has defied the natural life cycle of its peers, while other galaxies, including our own Milky Way, are vibrant factories constantly forging new, hot, blue stars from clouds of gas and dust. NGC 1277 is a celestial retirement home. It is composed almost entirely of ancient red stars, with no signs of youthful blue stars whatsoever. It is a galaxy that, for all intents and purposes, stopped evolving over 10 billion years ago. This presents a direct challenge to our standard models of galactic evolution, which are built on the idea of continuous change and renewal. Galaxies are supposed to be dynamic, cannibalizing smaller neighbors and recycling their own gas to birth new stellar generations. So what catastrophic event could have frozen this galaxy in its ancient state? One leading theory suggests a violent galactic robbery. NGC 1277 resides in the dense Perseus cluster, a crowded metropolis of galaxies. As it plowed through this intergalactic environment at tremendous speeds in its youth, the immense pressure from the cluster's superheated gas may have physically stripped away its own pristine hydrogen gas. Imagine a child running through a heavy downpour, their candy snatched from their hand by the sheer force of the wind. Without this raw material for star formation, the galaxy's creative engine simply shut down, leaving it stranded in time. Another possibility is that it formed in an unusually dense and frantic burst of activity during the universe's first 2 billion years, using up its entire gas supply in one glorious initial firestorm of star creation. The resulting gravitational pull from its dense core might have been too strong to allow fresh gas to cool and settle, permanently halting the process. NGC 1277 forces astronomers to ask a difficult question. Is our understanding of galaxy evolution incomplete? This runaway galaxy suggests that some cosmic islands can, against all odds, escape the relentless flow of time, preserving a pristine snapshot of the early universe and challenging the story we thought we knew. This coordinated motion, known as the dark flow, was uncovered by studying the subtle motions of massive galaxy clusters. Scientists meticulously mapped the movement of these colossal structures by observing the cosmic microwave background, the afterglow of the Big Bang itself. As galaxy clusters move through this radiation, they create a faint, telltale temperature shift, a kind of cosmic wake. The pattern revealed something astonishing. Hundreds of clusters scattered across billions of light years were all streaming in the same direction at incredible speeds, as if caught in a vast, unseen current. This was not the gentle drift of universal expansion. This was a directed flow, a coordinated march toward a point beyond our cosmic horizon. The known mass of our entire observable universe, with all its galaxies and dark matter, does not have enough gravitational pull to cause such a coherent motion. The force required to tug these titanic clusters must be unimaginably vast, and it must lie outside our field of view. This leads to a staggering possibility. The dark flow could be the gravitational tug of a structure so immense it exists beyond the observable edge of our universe. The most radical interpretation is that we are feeling the pull of another universe in a vast multiverse, a neighboring cosmic bubble exerting its influence from the outside. It is as if we live on an island and feel the tide from an ocean we cannot see. Of course, a claim this extraordinary faces intense skepticism. Critics argue it could be a statistical fluke, a subtle error in how we interpret the complex data from the cosmic background. Perhaps unknown local effects or imperfections in our measurements are creating the illusion of a flow. The debate continues, with newer observations both supporting and challenging the initial findings. Whether a ghostly current from another reality or a monumental error in our maps, the dark flow forces us to confront a humbling question. Are we truly seeing the entirety of the cosmos, or just the tiny, illuminated corner of a reality far grander and more interconnected than we ever dreamed? Our search for the universe's fundamental building blocks might be missing an entire dimension of reality. The world we understand is built from particles, tiny bits of matter with specific masses and properties that obey a strict set of rules. But what if there is something else, a kind of matter or energy that does not play by these rules at all? This is the radical proposal of unparticle physics. It suggests a hidden sector of the universe, a shadow realm made of what theorists call unstuff. Unlike electrons or quarks, unstuff is scale invariant. This means it has no single defined mass. It does not act like a distinct particle, but more like a continuous, cloud-like substance that behaves the same way at all energy levels. Imagine the difference between sand and water. A single grain of sand is a discrete particle, but a wave of water is a continuous whole. unparticle physics proposes that the universe might be filled with a cosmic ocean of this unstuff, and we have been trying to describe it using the language of sand. The evidence for such a bizarre idea is, as you would expect, incredibly subtle. It appears as faint anomalies in the data from high-energy particle colliders. Sometimes particles decay with a tiny bit of missing energy, or they scatter off each other at angles that don't quite match the predictions of the standard model. In the cosmos, certain high-energy events, like the collisions of dense stars, might release signatures that are just a little off, as if an invisible, non-particulate substance were subtly influencing the outcome. These discrepancies are so small they could easily be statistical flukes or measurement errors. Yet they persist, and they fit the mathematical profile of a scale-invariant force. If unparticle physics is real, its discovery would be more than just adding a new particle to the list. It would force a complete rewrite of our logical framework for reality. The very idea of a fundamental, particle-based universe would crumble, replaced by a far stranger picture where the lines between matter and energy, particle and wave, are blurred into irrelevance. We would have to accept that a ghostly, formless substance permeates everything, a hidden ingredient in the cosmic recipe that we never knew was there. The most massive stars in the cosmos live fast and die young, but a few choose a far more dramatic exit. Luminous blue variables are the unstable titans of the stellar world, hyperluminous behemoths so massive and energetic that they barely hold themselves together. They are prone to colossal, unpredictable eruptions, violently shedding entire solar masses of material into space in a single event. The most famous of these celestial time bombs is Eta Carinae, a binary star system whose own instability created one of the most spectacular stellar outbursts ever witnessed. In the 1840s, this star underwent what is now called the Great Eruption. Over the course of 2 decades, it violently expelled a vast amount of its own mass, becoming the second brightest point in the night sky, outshone only by Sirius. When the fury finally subsided, the ejected material formed the beautiful, billowing homunculus nebula, a bipolar cloud of gas and dust that still expands outward from the star system today. This was not a supernova, the final death of a star. It was a massive stellar temper tantrum, a partial self-destruction from which the star somehow survived. The internal mechanics driving such a violent event remain one of astrophysics' great puzzles. How does a star tear itself apart without completely dying? The leading theory suggests that at a certain threshold of mass, the outward pressure of radiation from the star's core becomes so immense that it begins to overpower the inward pull of gravity. The star becomes critically unstable, its outer layers so inflated and loosely bound that they can be blasted away by the sheer force of its own light. This presents a fundamental challenge to our models of stellar evolution. We simply do not know how to account for stars of such extreme mass, or why they exhibit this bizarre, eruptive behavior instead of following a more predictable life cycle. Eta Carinae is a ticking clock, a cosmic laboratory for studying the violent end stages of stellar life. Its continued instability suggests another great eruption, or even a final supernova, could occur at any time on a scale of years or centuries. When it finally does go, the explosion will be a spectacular light show, visible even in the daytime sky, a final, defiant act from a star that has already cheated death once. Far from the explosive deaths of distant stars, a mystery is unfolding in the frozen, dark frontier of our own solar system. The orbits of small, icy worlds beyond Neptune are telling a strange story, one that points to a ghostly giant hiding in the periphery. These distant objects, known as trans-Neptunian objects, do not follow random paths as we would expect. Instead, their orbits are mysteriously clustered, as if shepherded by an unseen hand. Their elongated paths are bunched together in a way that cannot be easily explained by the known planets alone. The gravitational math points to a single, compelling culprit, a hidden world with a mass up to 10 times that of Earth, orbiting the Sun in a vast, slow ellipse far beyond Pluto. This hypothetical world has been dubbed Planet 9. The challenge in finding this phantom planet is immense. At such an incredible distance, perhaps 400 to 800 times further from the Sun than Earth is, it would receive almost no sunlight. Any light it reflects back toward us would be incredibly faint, a dim speck lost in a sea of black. It is like trying to spot a single, dark piece of coal in a vast, pitch-black cavern using only a flickering candle. Astronomers are conducting a painstaking, pixel-by-pixel search of the sky, looking for this slow-moving needle in a cosmic haystack. The potential orbit is so enormous that it could take this world 15,000 to 20,000 years to complete a single journey around the Sun. If Planet 9 is real, its discovery would fundamentally rewrite the history of our cosmic neighborhood. How did such a large planet end up so far from the Sun? One leading theory suggests it was not born there, but was instead violently ejected from the inner solar system during the chaotic planetary migrations billions of years ago. The gravitational pull of Jupiter or Saturn may have flung it outward, but instead of escaping the solar system entirely, it was captured in a distant, stable orbit. Its presence would explain not only the peculiar orbits of the trans-Neptunian objects, but also the strange, tilted angle of the entire solar system relative to the Sun. This hidden world could be the key that unlocks the long-held secrets of our solar system's most turbulent early days, a fossil from an era of cosmic chaos that still governs the dance of the outer darkness. Einstein himself was deeply unsettled by a fundamental quantum phenomenon he famously dismissed as spooky action at a distance. This is quantum entanglement, a bizarre connection where two particles become inextricably linked, their fates intertwined no matter how far apart they travel. Change the property of one, like its spin, and its partner instantly responds, mirroring that change in a perfect, silent correlation. This connection appears to happen faster than light, shredding our classical understanding of cause and effect. For decades, physicists debated whether this was a real phenomenon or just a flaw in the theory. Then came the experiments. Scientists have now confirmed this spooky link over distances of hundreds of kilometers, sending entangled photons from the Canary Islands to satellites in orbit and observing the instantaneous correlation. To ensure they were truly seeing this ghostly connection, researchers have performed tests that close all conceivable loopholes, proving that the particles are not simply pre-programmed with hidden instructions. They are genuinely communicating, or at least acting as a single, unified entity, even when separated by vast stretches of empty space. So how can this be? The implications are staggering, suggesting a layer of reality where the universe is fundamentally non-local. It is as if two coins, flipped on opposite sides of the galaxy, always land on the same side, not by chance, but because they are two parts of a single, deeper whole. This challenges the very idea of separateness, hinting that the cosmos is woven together by an invisible web of connection that operates outside the speed of light. Could this quantum thread be the hidden stitch in the fabric of spacetime itself, a whisper of a deeper, more unified reality where everything is one? Even the chaotic heart of our galaxy holds a secret geometry. Near the supermassive black hole at the center of the Milky Way, astronomers have found a structure that looks less like an astronomical object and more like a fundamental blueprint for life itself. Stretching across 80 light-years of space, a vast nebula of magnetized gas twists into the unmistakable shape of a double helix, the same structure as a molecule of DNA. This cosmic spiral is not a trick of perspective. It is a real physical formation, a pair of entwined filaments coiling around a central axis, as if the universe itself were encoded with a familiar pattern. The sheer scale is breathtaking. This single, twisted ladder of energy and dust is longer than the distance between our Sun and its nearest stellar neighbors. How could such a perfectly ordered form arise in the most violent neighborhood of our galaxy? The answer lies in the immense gravitational dance orchestrated by the central black hole, Sagittarius, a star. Dense clouds of gas and dust orbit this gravitational monster at tremendous speeds. As they whip around, they drag the galaxy's powerful magnetic fields with them. Imagine stirring a cup of coffee with a spoon. The swirling liquid creates spiraling patterns on the surface. On a galactic scale, the orbital motion of these gas clouds acts like that spoon, twisting the magnetic field lines into a vast, rotating rope. The shearing forces between different orbital speeds then stretch and wind this rope into the tight, precise coils we observe. It is a natural machine for weaving chaos into order. This discovery reveals a profound truth about the cosmos. Ordered, complex structures can and do emerge from turbulent, energetic environments. You do not need a guiding intelligence to create a spiral of stunning symmetry. You only need the fundamental laws of physics playing out on an epic stage. The Double Helix Nebula stands as a beautiful, almost poetic, reminder that the universe has a hidden tendency toward organization, etching its most elegant patterns in the unlikeliest of places. These subtle imperfections in the cosmic background run deeper than a single axis. The Planck satellite's exquisitely detailed map of the universe's oldest light reveals a cosmos that is not perfectly uniform in its chaos. One of the most puzzling findings is a distinct temperature asymmetry between two opposing hemispheres of the sky. One half of the universe is, on average, slightly warmer than the other half. It is as if the primordial fireball of the Big Bang had a discernible left side and a right side, a fundamental lopsidedness that should not exist. This is compounded by another strange feature, a curious lack of correlation on the very largest scales. When scientists analyze the temperature fluctuations, they expect to see a consistent statistical relationship between hot and cold spots, regardless of the angular distance separating them. Yet, on scales wider than 60 degrees in the sky, this correlation virtually vanishes. The largest swaths of the universe seem to be operating independently, as if they were never in thermal contact with one another. These are not dramatic flaws, but quiet, statistical whispers that something in our standard story is amiss. The prevailing theory of cosmic inflation, a period of fantastically rapid expansion in the universe's first fraction of a second, was designed specifically to explain the overall uniformity we see. It proposes that the entire observable universe was once a tiny, connected region that ballooned out, smoothing any major irregularities. But these Planck anomalies present a direct challenge. How could inflation create a universe that is so uniform overall, yet still retain these subtle, hemisphere-wide imbalances and a lack of connection across its grandest dimensions? One radical possibility is that our universe is not infinite and uniform, but finite and oddly shaped. Perhaps the cosmos has a complex topology, like a hall of mirrors on a cosmic scale, where the largest patterns wrap around and connect in unexpected ways, creating the illusion of missing correlations. Alternatively, these imperfections could be a fossilized imprint from the moment of creation itself, a hint that the process of inflation was more complex, or perhaps even that multiple episodes of inflation occurred, leaving behind a layered and slightly flawed reality. These quiet anomalies remind us that the echo of creation still holds secrets, suggesting that the universe's first light may be telling a more intricate and mysterious story than we ever anticipated. Deep beneath the Antarctic ice, a silent sentinel waits for ghosts. The Ice Cube Neutrino Observatory is not a telescope in any traditional sense. It consists of thousands of sensitive optical sensors buried in a cubic kilometer of pristine ice, a colossal trap designed to catch the fleeting passage of the most elusive particles in existence, neutrinos. These ghostly particles are nearly massless, chargeless, and barely interact with matter, allowing trillions to pass through your body every second without a trace. For over a century, they drifted through our detectors from all directions, their cosmic origins a complete mystery. Then, on September 22, 2017, a single neutrino arrived with an address. It was not just any neutrino, but one carrying an immense amount of energy, a cosmic bullet from a source far beyond our galaxy. The alert went out across the global astronomical community. Within moments, telescopes of every kind swiveled to the coordinates provided by IceCube, searching for a counterpart, a visible or electromagnetic sign of the catastrophe that had launched this ghost. What they found was a blazing pinpoint of light, a blazar known as TXS0506+056, located 4 billion light-years away. A blazar is one of the most violently energetic objects in the universe. It is a galaxy centered on a supermassive black hole that is actively feasting on surrounding matter. As material spirals into the black hole, powerful magnetic fields funnel some of it away in two opposing jets of radiation and plasma traveling at nearly the speed of light. In the case of a blazar, one of these devastatingly powerful jets is pointed directly at Earth, making it appear as an intensely bright beacon across the cosmic void. The detection of a high-energy neutrino from this specific blazar was a monumental breakthrough. It was the first time we had ever traced a single neutrino back to its astrophysical birthplace. This event marked the triumphant dawn of multi-messenger astronomy, a new way of seeing the cosmos. For all of human history, we have studied the universe using just one messenger, light, across all its wavelengths. Now we could combine that ancient sense of sight with a new one, the sense of touch. We could feel the universe through these ghostly particles. The confirmation was profound. It proved that the engines of these cosmic monsters, blazars, are natural particle accelerators of almost unimaginable power. They are the factories that can take these near-weightless ghosts and fire them across billions of light-years, imbuing them with energies that dwarf anything we can create on Earth. This solved the long-standing mystery of where high-energy neutrinos come from, but it instantly opened a new and more thrilling door. Neutrinos, unlike light, travel in a perfectly straight line, unaffected by magnetic fields. They are unedited messages from the heart of the most extreme environments in the cosmos. By combining their pure information with the light from telescopes, we can now peer directly into the central engines of black holes, into the hearts of exploding stars, and into the violent births of gamma-ray bursts. We are no longer just watching the cosmic fireworks, we are feeling the shockwaves. Sometimes the most tantalizing discoveries are the ones that ultimately defy our hopes. A few years ago, a concept emerged from the fringes of physics that promised to revolutionize space travel, an engine that needed no fuel. Dubbed the M drive for electromagnetic drive, it was a sealed, cone-shaped metal cavity. When you pumped it full of microwaves bouncing around inside, its proponents claimed it produced a tiny, persistent thrust. This was a staggering claim. It seemed to create a push from nothing, a force without an equal and opposite reaction. It appeared to blatantly violate Newton's third law of motion, the fundamental principle that for every action there is an equal and opposite reaction. Rockets work by violently expelling propellant out the back, the action which thrusts the vehicle forward, the reaction. The M drive had nothing to expel. It was like sitting in a car and trying to move it forward by pushing on the windshield from the inside. The initial, small-scale tests reported a faint but measurable thrust, and the excitement was electric. Imagine spacecraft that could travel the solar system without carrying immense tanks of heavy fuel, a genuine breakthrough for human exploration. The potential was so alluring that even NASA established an advanced physics group to investigate it. The true test of any extraordinary claim, however, is whether it can be replicated under rigorously controlled conditions. As more teams built their own M drives and placed them in vacuum chambers on incredibly sensitive thrust balances, the dream began to crumble. One by one, the results came back null. The most telling experiments were those that rotated the device. If the thrust was genuine and internal, rotating the engine should not change its direction. But it did. The measured force shifted with the orientation of the apparatus, a clear fingerprint of an external influence. The culprit was most likely the Earth's magnetic field interacting with the electrical currents powering the device. The thrust was an illusion, a subtle experimental error masquerading as a physics-shattering discovery. The M drive now stands as a powerful case study in how science self-corrects. The process is not about proving ideas right, but about trying everything possible to prove them wrong. A claim that defies core logic faces an uphill battle, and for good reason. Yet this pursuit of the impossible is not a waste. It forces us to refine our instruments to incredible precision, to question our assumptions, and to explore the very edges of our understanding. Even in failure, it propels us forward, reminding us that the line between a revolutionary breakthrough and a dead end is often vanishingly thin. Even the rate of the universe's expansion is now a subject of fierce debate. At the heart of this crisis is a number called the Hubble constant, which tells us how fast the cosmos is stretching for every million light-years of space. For decades, astronomers have worked to pin down this single, crucial figure, the ultimate speedometer of the universe. They have refined two primary methods to an astonishing degree of precision, yet these two paths lead to stubbornly different destinations. The first method looks back to the very beginning, using the cosmic microwave background. This fossilized light from the infant universe gives us a pristine snapshot of its initial conditions. By applying our best models of cosmology, we can run the clock forward and predict what the expansion rate should be today. This approach yields a very specific, reliable number. The second method builds a cosmic ladder step by step into our modern universe. It uses pulsating stars called Cepheid variables and cataclysmic supernova in relatively nearby galaxies to measure distances with incredible care. By seeing how fast these galaxies are rushing away from us, we get a direct local measurement of the current expansion rate. Each technique is a masterpiece of modern science honed over countless experiments. The problem is, they do not agree. The local measurement says the universe is expanding significantly faster than the primordial measurement predicts. This is not a small statistical fluke. It is a persistent and growing discrepancy known as the Hubble tension. Imagine two of the world's most accurate clocks, one built from the blueprint of creation and the other meticulously calibrated by observing the present day. They are both ticking perfectly, but they steadily tell different times. This conflict suggests that our standard model of cosmology, which has been overwhelmingly successful, might be missing a crucial ingredient. Perhaps dark energy, the mysterious force driving the acceleration, is not constant as we have assumed. Maybe it evolved over time, growing stronger or changing its nature, causing the expansion to speed up more than our models allow. Or the issue could be even more profound. The early universe might have contained a new, previously unknown type of relativistic particle, or dark matter might interact in ways we have not yet accounted for. Some physicists even speculate that this tension is a hint that our understanding of gravity itself needs a fundamental revision. The Hubble tension is more than a scientific disagreement. It is a beacon illuminating a potential crack in our foundational knowledge and pointing toward new physics waiting to be discovered in the vast, expanding dark. From the ghostly pull of the Great Attractor to the violent birth of neutrinos in distant blazars, this journey has revealed a cosmos that is fundamentally bizarre. These 30 discoveries are not isolated quirks. They are a collective testament to a universe that thrives on mystery, constantly challenging the limits of our comprehension. The silent void of the Fermi paradox, the perfect geometry of the red rectangle, and the unsettling tension in the Hubble constant all whisper the same profound truth. Our reality is far stranger and more wonderful than we ever dared to imagine. These puzzles are not failures of science. They are its very engine, the compelling questions that pull us forward, driving innovation and deepening our awe. Every mystery solved simply reveals a new layer of the unknown, a more beautiful and complex puzzle waiting to be unraveled. So the next time you find yourself under a clear night sky, look up. Remember that you are not just looking at points of light. You are witnessing a grand, ongoing cosmic drama, a story written in gravity, energy, and ghostly particles, a story that is still being written. Let that sight fill you with a sense of wonder. Stay curious, keep questioning, and remember that you are part of a species brave enough to stare into the abyss and demand answers. We want to know which of these cosmic mysteries baffles you the most. Share your thoughts in the comments below, and let's continue this adventure together as a community of explorers forever reaching for the stars.